Join the 28-hour SQL Server Masterclass on the Udemy platform for only $15 instead of $89. Learn how to become a future developer or either a future DBA or performance expert on SQL Server with 150 exercises. The link to the promotion is in the video description. Okay? Want to get started on SQL Server? Then join me. Okay, so let's see in detail the explanation of the covering index. Okay, we will use our database as usual, structured index, and we will analyze the employee table. So let's run the exec sp index. So the table contains three indexes. Okay, a clustered index on the employee ID column, a non-cluster index on the employee ID and SSN, and another non-cluster index for the SSN column. Okay, so let's activate the statistic and the execution plan. So let's go. Let's run this query with the filter on the SSN column between and two values. We can see that it was fast, and if we check the logical with it's 44. Okay, so 44. Execution plan is not activate. I'll enable it, and we can see that the seek takes 2%, and we go on the KLOOKUP, which takes 98% of the request. It's huge. So why is taking 98%? Okay, so because we have the clustered index on employee ID and a predicate on the SSN column, which is a non-clustered index. Okay, so what's going to happen in this query is that the query will do a seek in the clustered index, okay, on the employee ID, but since the query requires other columns for the SSN, so the SSN column, it will add columns that are not in the clustered index. You understand? So it will spend its time looking for the data in another column with the KLOOKUP. So for the SSN column, and it will also look taking 98% for the values that are in the employee ID column. Okay, so it's 100% for these two queries, these two operators. 98% plus 2% equal 100% in all. Okay, so remember, what you have to do is, as soon as you see a KLOOKUP, it should absolutely disappear from your execution plan. It's very consuming in some cases. So as soon as you see a clustered index, if there is a KLOOKUP that is not in your query, it does a KLOOKUP. So the KLOOKUP always appears with the clustered index. Therefore, that there must be eliminated as quickly as possible. Okay? So what must be done in this case? Instead of making a select start with all the columns, you just need to add the SSN column, okay, with the employee ID, which will encompass the entire query. So let's run the query, and you can see it's switched to the sync index, okay, which will take the non-cluster index. Here it no longer goes into a cluster 1 index, okay, and you can see that the logical width it's now 2 pages. So in this case, the trick was not to create an index, but it was just to add the column that was part of the cluster 1 index. And what if we do a select that brings back more data? For this example, I will run this query, and what's happening is very interesting. We have 4009 page, okay, and 6,000, around 6,000 rows brought back. So for the logical operator, it did a scan plan, index scan, and not a seek, because SQL decided that it was much faster to do a scan than going through a seek index and a KLOOKUP. Okay, it's SQL that has decided to do an index scan. And if we take the same request and put the SSN column, okay, with more data, so let's run the query, and we have 19 logical reads, okay, which is much less than 4,000, okay. So we see that adding the SSN column, it takes the non-cluster indexing, okay. So let's example this query, it will bring all the rows, okay, with this filter. So let's run the query, and you can see that instead of going through a scan index, SQL is going to go straight to search index, because it finds that it's much faster to go through a sync index than a scan index. Okay, we have 210 logical widths, and for this query, without this filter, it's the same thing. Huh? It's the same thing for the query. It's the same rows bring back, and if we get a look on the two execution plan, it's the same 50% for the two queries. Okay, so here we take the whole table in both cases. So what will happen? So we see that it's that SQL Server is smart about this. The algorithm is very powerful. We are at 15% to the seek and 50% for the scan index. So we see that in some cases the scan index is not less efficient than the sync index. Okay? So personally, what I do sometimes, when we don't have filters, we do a scan index. We can put a predicate to look for a cluster 1 index to bring back data more quickly. Okay? In summary, you should limit the number of columns in your SQL query. It's very important. Limit the number of your columns. Okay, don't do a select star from your table. It will never do a seek. It will always to do a scan index or a key lookups. Okay, so this can be a great benefit to indexes in place or to be created. So do not never with the select start or a key lookup in your execution plan. Okay, so let's go to the next demonstration.